So today we're going to see two-step equations, which an equation, it can be written in ax plus b equals to c. That's standard form. So in case you were to have an x squared, it would be ax squared plus bx plus a constant equals another constant. So I'm just going to write c again. So the standard form is always the x first, then the variable or the constant, and then another constant. Now, on the next slide, let's solve these. For the first one, we're going to add that 3 on both sides in order to solve for that x. So it's going to be x is equal to -5 plus 3. Now, the reason I would like you guys to write down that you're adding it is because you realize the -5 and the 3 are two different signs. Therefore, it would make a lot of sense for you guys to realize they're two different signs. We're going to subtract 5 minus 3 is 2, and we keep the sign of the biggest number. Now, this question was asked, what if you do it the other way? If I add the 5 instead of the 3, we're going to get x is equal, or x plus 2 is equal to 0. Then I'm going to move the x to the other side, and it's going to give us 2 is equal to -x, which at the end I'm going to multiply this whole thing times -1 in order to get that -2 is equal to x. Now, the order doesn't matter as long as you follow the rules and the variable is positive at the end. Now, let's do b. I'm going to subtract the 2.8 on both sides, so this one's going to cancel out. Now again, two different signs, so I'm going to do 2.8 minus 0.9. I'm going to get 1.9. Now it's going to be negative because the 2.8 is the bigger number and it has the 1 with the sign, so therefore it's -1.9y. Alright, so for the first one, I'm going to just rewrite it. Now I'm going to multiply both sides times -5. These are going to cancel out and we're going to get n is equal to 15. I want you guys to realize that that fraction, that negative n over 5, the negative can belong to the n, but it can also belong to the 5. So that's why we multiply by -5 to get rid of that fraction. Now, the in-between step of why those cancel out is because when we multiply this out, we get -5n over -5, which is going to simplify, the negatives become a positive and the 5 simplify to just n. Now for the next one, we have pi x equals -2 pi. Now, I want you guys to realize that you guys can do the same thing you can do with pi with any other number. So, usually we divide by pi. On both sides, it's going to cancel out because of the same thing I showed you guys here. So, it's going to be x is equal to -2 pi over pi, which the pi's are going to cancel out. And we're just going to be left with x is equal to -2. And for c, we have 1.3z equals 5.2. Now we're going to divide 1.3 on both sides. We get that z is that division, 5.2 divided by 1.3. So when I put it in right here, can the outside number have a decimal? No, it cannot. So I'm going to go ahead and actually remove it in the sense that I'm going to move it over once over here and once over here. So it makes the decimal disappear. So we're left with 52. Sorry, that's a square root sign. 52 divided by 13. I'm going to plug in number 4 to try it out. 13 times 4 is 52. So it works out. Therefore, z is equal to 4. So guys, to solve two-step equations, you gotta think of PEMDAS backwards. Now, not in the solving sense. You still want to solve in the same order of parentheses, exponents, multiplication, division, addition, and subtraction. But to get the variable alone, you're gonna have to work backwards. So for example, we've been using this example a few times. So PEMDAS backwards would be addition or subtraction first. In this case, we can subtract that 2 as the first step in order to get that variable alone. In doing that, we go backwards. Can I move anything else? No, we cannot. So now we're going to do multiplication of division. Now, since the 3 and the x are being multiplied, we're going to divide by 3. Remember, it's always the inverse operation. So x equals 9 divided by 3 is just 3. So we still solve in the same order, but in order to find the variable, we have to work backwards. Now, these are some helpful tips. You first want to identify what operations are on the variable side. So we add or subtract, multiply or divide them, like we did in the other one. The first thing we did, I'm just going to rewrite it. The first thing we notice is, hey, this 2 term is not with the x. Let's move it over. So we move it to the other side by subtracting. That's what we did. And again, whatever you do one side, in this case subtraction, we do it to both. Remember, always on both sides. So we're gonna get, sorry, this was supposed to be not a 2, but an 11. We're gonna do it on both sides. Same thing happens. Again, what else do I need to do to get that x alone? We're gonna divide it by 3 on both sides, which left us again with x is equal to 3. Now, the key part, whatever you do one side, you have to do to the other. I cannot stress that enough. Okay, so for the first one, we see what we need to find. We need to find this x. So anything that's not with that x, we're gonna move to the other side. So we're gonna add 13 in this case. This one cancels out. So we're gonna get 2.5x equals 15. So x equals 15 over 2.5 because I divided on both sides. Again, you can't have a decimal for dividing. So we're going to get 15 and then 2.5. Now we're going to move that 0. So we have to add a 0 here, guys. Remember, if I multiply one side by 10, I have to multiply the other side by 10. That is the key part. Now I'm going to try 6. So let's do 25 times 6. 6 times 5 is 30. Carry the 3. 6 times 2 is 12. So we get 150. That's going to simplify to 0. So x is equal to 6. I'm going to go ahead and erase the multiplication so I can have a little more space. Now, just for right now, I'm going to also erase the division, and I'm going to rewrite this at the bottom to have a little bit more space. Now let's do the second one. The first thing I noticed, can I combine something? There's 2 x's. So yes, I can combine them. They're actually on the same side already. Makes it easier. Negative 12 equals 9x minus 6x is 3x plus 15. Now, since I want to solve for the x, I have to move everything else to the other side in order to get it alone. I'm going to subtract the 15 on both sides. And I'm going to get negative 27 is equal to 3x. Again, since it's being multiplied, I'm going to divide by 3 on both sides. And I'm going to get that x is equal to negative 9. Now for example 3, there's actually different ways you can solve it. I'm going to show you 2 different ways. Still going to get the same answer. The first thing I'm going to do is I'm going to subtract this 3 on both sides. Which is going to give me a negative 11. Then I'm going to distribute that 2. So I'm going to get 2 minus 2x is equal to negative 11. Afterwards, I'm still trying to solve for that x. So I'm going to subtract that 2 on the other side in order to leave the x alone. So I'm going to get negative 13. And lastly, I'm going to divide by negative 2 on both sides, which is going to give me x is equal to 13 over 2. I will be okay if you guys leave it as a fraction. Now, I'm going to erase the work for the other ones so I can show you the other way. You can solve it. Now, a different way you can solve it, I'm just going to rewrite it right here. You can distribute first and do 2 minus 2x plus 3 equals to negative 8. Combine like terms, which are this 2 and this 3. So we're going to get negative 2x plus 5 equals negative x. Then I'm going to subtract by 5 on both sides to cancel that out. This is going to give me negative 13. When I divide by negative 2, just like the other one, it's going to give me 13 over 2. Again, the negatives with the negatives make a positive when dividing. Now, another way you can solve this is I'm just going to rewrite it. Again, the first thing for this one is I'm going to subtract the 3 on both sides. We're going to get a negative 11. Now, I'm going to actually divide by 2 both sides to get rid of this 2 in front of it. So I'm left with 1 minus x is equal to negative 11 over 2. Then I'm going to subtract the 1 on both sides. In order to get that 1 to be able to subtract it from that fraction, I'm going to have to make it a fraction 2 over 2. So I'm going to get negative x is equal to negative 13 over 2. Now, this negative needs to go, so I'm going to multiply both the left and the right by negative 1, which is going to give me x is equal to negative 13 over 2. So it doesn't matter which way you do it, you're still going to get the same answer. Okay, so remember, just choose the way you like the best. There's other ways you can do it. You can add some numbers, subtract some others. You're still going to get the same answer as long as you follow the correct rules and procedures to get this. Now, these are steps for solving two-step equations, so PEMDAS backwards. The same thing we did, do we need to distribute, do we need to combine like terms, and then we'll work PEMDAS backwards. In this case, I'm going to follow this. Do we need to distribute that example? Yes, we do, right there. 6 times 6 is 36v plus 36 minus 5 equals 1 plus 6v. There's nothing else to distribute. Can we combine like terms? Yes, we can. That 36 right here and this negative 5. So we're going to do 36v plus 31 equals 1 plus 6v. Now, we work PEMDAS backwards. I notice that we have a v on the left and a v on the right. I'm just going to go ahead and move that 6v. So 36v minus 6v is going to give us 30v plus 31 equals 1. Okay, now this is more or something closer to what we're used to solving. Now we're going to move that 31 to the other side since we want to leave the v alone. And it's going to give us 30v is equal to negative 30. So when I divide both sides by 30, I'm going to get that v is equal to -1. All right, so that is it for this lesson.